Okay, this is Chapter 3, Exponents and Powers Practice Test. Today's date is October 23rd. First 6 questions are true, false. It says 5 to an exponent of 4 is equal to 5 times 5 times 5 times 5. And the answer, of course, for this is true because exponential form or powers symbolize repeated multiplication. The base being 5 is to be multiplied by itself 4 times. So 1, 2, 3, 4, that's what the exponent is for, and the 5 is the base, which is what's used in repeated multiplication. Question 2 says negative 2 in brackets to the exponent of 2 is equal to negative 2 not in brackets to the exponent of 2, and the answer to this is false. And the reason why is the brackets here are defining the base. So when your base is in brackets, then that means it is used then in repeated multiplication. So in this case, this would be negative 2 multiplied by itself twice, meaning it would have a standard form value of 4. But because there are no brackets around this one, we can think of it in 2 ways. I like to think of it as the opposite of. I like to think of this negative sign as being the opposite of, on a number line, 2 squared, which of course, since 2 squared is 4, the opposite of 4 would be negative 4. Some people like to teach it as a negative 1 coefficient, so you can think of it as this as well. Since 2 squared is 4, then multiplying it by negative 1 would still give you a negative 4. So the answer for this one is false. Question 3 is asking you to apply your exponent rules or laws. The first one is the multiplication of 2 powers that have the same base. So your rule is when you are multiplying, keep the base and add your exponents to get negative 2 in brackets to the exponent of 9. And this would be divided by negative 2 in brackets to the exponent of 2. And now we use our second law, which says when dividing like bases with different exponents, is keep the base and subtract your exponents to give you a final answer of negative 2 in brackets to the exponent of 7. So you've determined that the actual answer is negative 2 to the 7. It says that it should be negative 2 to the 18, so therefore the answer is false. The actual answer is negative 2 to the exponent of 7. Question 4 says 2 times 5 cubed is the same thing or is equal to 8 times 125. Asking you if you know that when you are multiplying numbers together in brackets with an exponent outside, you can disperse the exponent to all the parts of your product or quotient, in this case a product, which means you can think of this as being 2 squared, or sorry, 2 cubed, multiplied by 5 cubed. Since 2 cubed is 8 and 5 cubed is 125, the answer would be true. They are the same thing because of the power law. Question 5 says negative 2 times negative 3 in brackets to the power of 4. So because we have this negative 3 in brackets with an exponent of 4 outside, that means that negative 3 is used in repeated multiplication. And I'm not going to do this first because that would not be following bedfence. I'm going to do my exponents first. So negative 3 multiplied by itself 4 times. Negative 3 times negative 3 is 9, and 9 times 9 is 81. So therefore, negative 3 multiplied by itself 4 times is a positive 81. So my next line will be this. And negative 2 times 81 is negative 162. And is negative 162 greater than 0? No, it's not. So your answer is false. Question 6, your last of your true false says negative 2 in brackets. So the reason why the round brackets are there is because it's defining the base as negative 2. The exponent of 2 is what negative 2 has an exponent of, and then all of that is to an exponent of 3. Your law says when you have a power to an exponent, keep your base and multiply your exponents together. So you're going to have negative 2 to an exponent of 6. And will that be greater than 0? Now, I don't have to solve it because I know that a negative base to an even exponent is going to be a positive answer. And it's going to be a positive something. I don't know what it is. I don't care really. But a positive anything, never mind a positive something, will always be greater than 0. In the case of negative 2 to the 6, 2, 4, 8, 16, 32, 64, it's actually a positive 64 if you wanted to solve it. But I like the fact that you know that a negative base to an even exponent will be positive, and that will always be greater than 0. Your next question says complete the table. So you're given the power of -3 in brackets to the exponent of 4. In repeated multiplication, that's -3 multiplied by itself 4 times. And again, negative base to an even exponent will be a positive value. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. This says the opposite of 10 times 10 times 10. So the opposite of 10 cubed is how you would write it in as a power. No brackets around anything, because that's the opposite of 10 cubed. And that would be -1000 as a value. Now, the value here is given as 216, and you're saying, I don't know the base, but I know it's cubed. So the easiest way to tell you how to do this is just trial and error. So let's pretend it was 10. So if you tried 10 first, and you say, well, what's 10 times 10 times 10? Well, 10 times 10 times 10 is 1,000, so you know that the base of 10 is too high. So then you try 5, and you go 5 times 5 times 5, which is 125. That's too low. So you know your base has to be somewhere between 5 and 10. So you try 6. 6 times 6 times 6 is what 6 cubed is. 6 times 6 is 36. 36 times 6, aha, is 216. So your answer is 6. And there is your repeated multiplication to give you the value of 216. In the expression -3 times 4 squared, what do you call the 2? The 2 is called the exponent. The -3 is called the coefficient, or numerical coefficient, and the 4 is called the base. Next question, I know it's not numbered properly. My computer, for whatever reason, didn't do it. It says, write as the product of two powers. So the product of two powers first will be 2 to the exponent of 4 multiplied by 2 to the exponent of 2. That is the product, meaning the multiplication of two different powers. Once you have that, it says write it as a single power, which, because your base is the same, you can keep your base and add your exponents to give you 2 to the exponent of 6, and state its value. Well, 2 to the exponent of 6, 2, 4, 8, 16, 32 is 64. Right is the quotient of two powers. So for this one, you have 8 being multiplied by itself 5 times, which is 8 to the power 5, divided by 8 to the power 3. Now you could do it like this. Both of them are the same thing. So that's expressing as the quotient of two powers either way. As a single power, because the bases are the same, you can keep the base and subtract your exponents, giving you 8 squared, or same thing here, give you 8 squared. And as a single power, or as a value, the answer is 64. And that's the completion of this question. Right as a power to an exponent. So here you have 10 squared being multiplied by itself 4 times. So you have 10 squared being multiplied by itself 4 times. So that is a power to an exponent, right? 10 squared multiplied by itself 4 times. Right as a single power, well, the rule is when you have a power to an exponent, keep the base and multiply your exponents. So as a single power, it would be 10 to the 8. And state its value. When you have base 10 to any exponent, put a 1 down, and the exponent, when your base is 10, will be the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. And therefore, you have 100 million as its value. Arrange the powers in descending order of value. So we have 4 powers set up there. The strategy for this would be, of course, to find the standard value of each. This says the opposite of 4 squared, because there are no brackets around the -4, which means it's not its base. So in repeated multiplication, it would be the opposite of 4 times 4. 4 times 4 is 16, the opposite of which is -16. The brackets are around this -2, which means it's used in repeated multiplication. So -2 times -2 times -2 times -2. A negative base to an even exponent will be a positive. 2, 4, 8, 16. That'll be a positive 16 for that. The base is -1 to an exponent of 13. A negative base to an odd exponent will be negative, and 1 multiplied by itself any number of times will still be 1. So -1 to the exponent of 13 is still -1. The base here is -10, and what we learned is any base to the exponent of 1 will be itself. So that will be a -10. And the last question, any base to an exponent of 0 will be itself, or will be 1, excuse me. So 2 to the 0 will have a standard form or a value of 1. And it says arrange these in descending order, so I got to start with the biggest number. So the biggest number was this one, because it gave me a 16. My next biggest was 1, which will be 2 to the 0. My next biggest was this one, which is negative 1 to the 13. Then negative 10 to the 1. And finally, negative 4 without brackets squared. For questions 13 to 18, use BEDMAS to solve. Show all work. So there's no brackets around the negative 2, which means it's the opposite of 2 times 2 times 2 times 2. 4, 8, 16. This will be a negative 16 in standard form. Plus, the brackets are around the negative 3, which means it's used in repeated multiplication. A negative base to an odd exponent is a negative value. 3 times 3 is 9. 9 times 3 is 27. Finally, we have a grade 7 question. Negative 16 plus negative 67 is negative 43, which is your answer for this next question. Question 13. Question 14. Is 3 cubed minus 8 minus 2 squared plus 1 to the power of 6. Use BEDMAS. Solve your brackets first. So 3 cubed minus 6 squared plus 1 to the power of 6 when I solve my brackets first. Some people think you can take the 2 and disperse it to the parts inside the brackets, but that rule only works when you're multiplying and dividing, not when you're adding or subtracting. Now we have 3 powers. In standard form, 3 cubed is 27 because it's 3 times 3 times 3. Minus 36, which is 6 squared, plus 1 to the 6 is not 6. It's 1 multiplied by itself 6 times, which is still 1. 27 take away 36 is negative 9. And finally, negative 9 plus 1 is negative 8. Question 20 or whatever it is, I have no idea. What is it? Question 15? 15. Question 15, you have brackets that you have to solve. 5 take away 8 is not 3, people. It's negative 3. So when I solve the brackets, that's what I get. Now I have 2 powers. Negative 3 cubed is negative 3 multiplied by itself thricely, which is negative 27. Negative 2 multiplied by itself 3 times is negative 8. When I add those together, I get negative 35. Negative 35. Next question, which is not 11. 2 to the 5 times 2 squared plus 10 to the 0 times 10 to the 3 divided by negative 2, not in brackets, exponent 1. So I'm going to use I can do one of two things. I could either solve that as being 32 times 4, or say that's going to be 2 to the exponent of 7, which in standard form, 2, 4, 8, 16, 32, 64 is 128, plus 10 to the 0 is 1, and 10 cubed is 1,000. So 1 times 1,000 is 1,000. Divided by, now remember, the negative 2 is not in brackets, which means it's the opposite of 2 to the exponent of 1. 2 to the exponent of 1 is 2, and the opposite of that is negative 2. So when I solve that, I get 1,128 divided by negative 2. Watch how I do this. I'm going to divide all of these parts by 2. Half of this is 500. Half of this is 50. Half of this is 10. And half of this is 4. So therefore, 550, 560, 564 is what 1,128 is divided by 2. A positive divided by a negative is a negative. Question 12 says 1/3 squared. I think I changed this to a 2, didn't I? I made it a 2 there. Plus 1/2 cubed. So I can do one of two things. Since this is actually thought of as either, you can also think of this as being 1 divided by 3 squared, or a fraction squared. You apply the 2 to both parts. So 1 squared will be 1 over 3 squared, which will be 9. Plus, apply the 3 here to the 3 and the 2. 1 cubed over 2 cubed will be plus 1 over 8. Addition of these two fractions requires a common denominator, which we'll use 72. That's going to be 8 over 72 as an equivalent fraction, and 9 over 72 as an equivalent fraction, which makes your final answer 17 over 72. Question 13 is 100 take away negative 9 in brackets squared minus 5 times negative 3 in brackets squared. So 100 take away 81 take away. This is going to be 5 times positive 9 because negative 3 squared is 9. It's going to be take away of 45. 81 take away, 100 take away 81 is 19. And 19 take away 45 is 30, 26 negative, negative 26. Now that's where you can use your calculator, of course, and go, what is 19 take away 45? It says negative 26, and you get Bob's your uncle. No problem. And your last question on the practice test is 10 bacterium in a petri dish. They will triple every 2 minutes. How many will there be after 20 minutes? So your formula is this. So our starting number right here is going to be 10. That's how many bacterium start. Our rate of change is right here. It triples, and tripling is signified by the number 3. Now the number of time units, some people thought it was 20, but it's not going to triple 20 times. Since it triples every 2 minutes, and we're doing it for a duration of 20 minutes, that means the number of time units it's going to triple is going to be 10 times. It's going to triple 10 times within that 20 minutes because it does it every 2 minutes, so 10 times. And that is what we would use as a coefficient and power. First simplified my power, I said 3 to the exponent of 10, which is 3 multiplied by itself 10 times, is going to be 59,049. Multiply that by 10 again, you just add a 0 onto it, 590, 490, I think that's what it was it? Yeah. So 59049 is what 10 cubed is. And therefore, there will be over 500,000 bacteria after 20 minutes.